Yeah, we have another Ananya today. She's taking the place of Sana. So Sana is dropping out of the program, and instead have asked. Ananya's mom had requested, so she's on from today. Okay, I don't know. A lot of absentees today. I know a few of them had messaged saying they have exams and stuff, but let's see. Okay, all right. It's already 5 minutes up, right? So we can get started. Let me just share screen. Are you seeing this?
So
Okay.
this homework that you had given us,
Yeah,
most of it, there were just too many sums for me to do. So there were like some 20 sums, I think, or 15 sums,
15. There are
15.
15.
Yeah.
Yeah,
I
usually it's
did a
around.
few of them, but I couldn't do more, all of them.
That's fine. We'll discuss. No problem. We'll discuss. As long as you tried them, that's more important. You should have spent
But
time
I
thinking through
think
them.
these questions I've done in school before. These, I think, IGCSE questions.
I picked these questions from IB. This is for your
Okay.
regular, just like a warm-up type of questions before we come to the regular AMC10 questions. Yeah. Okay. So let's see. But before we get started, I just wanted to quickly cover some of the basics on permutation, combination, probability. Okay. All of you seeing my screen, right?
Yeah.
Okay. All right. So there are two things in just so that some of you have been bringing from the beginning of the program, some of you have joined in midway. So I mean, like for example, Avinash and like Kunal and few others, right? All they are joined middle of the program. So let me just quickly recap permutation and combination. So there are two things. So permutation is arranging. So permutation is the arranging game. And combination is choosing. So combination is choosing. So both of them together come under something called combinatorics. Okay, and of course, probability you will need both, right? So probability is just, as you know, favorable cases by total cases. So favorable by total. Okay, and to calculate both favorable and to calculate the total number of cases, we'll need permutation combination depending on the question. Okay, so that's the high level. Now, first we'll do choosing. First, we'll do the combination part. So typically, the problem statement is you have a collection. So let's say you have like A, B, C, D. I'm just randomly drawing them so that just to dispel any notion of order. So A, B, C, D, E, F, G. Let's say these are 7 students in class. Okay. Now, I have to choose 3. Let's say the teacher has to select 3 from this. So that's denoted by 7, choose 3. Okay. So it's also denoted as 7, 7, 3 like this. Both of these notations meaning of 7 objects, we have to choose 3. Now, how would you typically do it? You'll pick one. Okay, let's say you pick F first, and then let's say you pick A, and then after that you pick C. Okay. Now, whether you picked A, FC, or FAC, or FCA, all of them, effectively, they are the same, right? That's the same collection. So if I naively count the number of ways as I can call any one of the 7 letters for the first, and then I can call any one of the 6, any one of the 5, then that'll be excess counting, right? So I'll have to divide by the excess counting. Okay, so how many times am I excess counting for each group of 3 letters? It's the number of ways in which I can arrange A, F, and C between them, right? So that's like, for example, you can clearly see that there are 6 of them, right? A, C, F. If I arrange them in alphabetical order, there'll be 6 of them. I've listed 3 as an example here, but if I start alphabetically, it's A, C, F, C, A, F, C, A, F, C, F, A, and then F, A, C, F, C, A. So that's 3 factorial, right? Or 6. So the excess counting that's happening here is the number of ways in which I can arrange them, right? I can arrange the chosen 3. So that's 3 factorial. 3 factorial. Okay. Now, this is easy to write for small numbers, but just imagine, suppose it's 100, choose 20, right? So you'll do the same thing. You'll do 100 into 99 into 98, all the way till 20 numbers from here will end in 81 upon 20 factorial. So the bottom was easy to write as 20 factorial, but the numerator was little difficult to write as 100 into 99 and show all the way till dot 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 till 81. So to make it easier, a simple trick that people devised is you can multiply and divide the numerator and denominator by some quantity, right? For example, if it helps me, I can multiply numerator and denominator by 7 without disturbing anything, right? I can multiply and denominator by anything. Let's say I choose to multiply by 80 factorial. So if I do that, what happens? The numerator now becomes all the way from 100 back to 1. So it becomes 100 factorial. And the denominator becomes 100 factorial by 20 factorial into 80 factorial. So even though numerically we have already done 765 by 321, it's easier to write it as 7 factorial by 3 factorial into 4 factorial. Okay. Or more generally, if I have n choose r, right? From n objects, if I have to select r objects, also known as NCR like this, both of these notations are valid. It's just simply n factorial by r factorial times n minus r factorial. Okay. All right. So that's the choosing part. And typically, the common ones for all our problems will be choosing 1, choosing 2, choosing 3, or maximum choosing 4. But let's see a few simple things, right? So suppose it's 8 choose 1. You don't need any combinatorics to figure out the answer is 8, right? Of 8 people, I'll have to select 1, right? That's any kindergarten student will tell you that it's 8 ways, right? I have to literally select 1. You don't need any high math for it, right? But surprisingly, it's 8 choose 7 is also 1. It's also 8. So why is that? If I have a group of 8, if I have to select 7, I'm not going to be picking 7, right? I'll just say it's not selected. You are out. Okay, the rest of you are in. So I can do that you are out business in 8 different ways, right? I can select any one of them and say you are out. So selecting and unselecting are happening simultaneously. So whichever is the smaller group, I can do that, and the other group is automatically decided. So similarly, exaggerating a little bit, so if it's 100 people, I'll have to select 97. I'm not going to select 97. I'll just select 3. So the number of ways in which I can select 97 is exactly same as the number of ways I can select 3. What I choose to do with the selected 3 or the selected 97, depending on, I ask them to stand in the left and the right, let's say, right? What I choose to do that is a later business. For now, I've separated them, right? How many ways can I separate them? It's 100 choose 3, which is same as 100 choose 97. Okay, and the formula also tells us the same thing, right? Suppose it's n choose n minus r, that'll also be the same, because what will happen if I expand this? It'll be n factorial by n minus r factorial times n minus r. That's what the formula tells us, right? N minus r, which is back to r. So this is effectively r factorial. So both of these quantities are effectively same. So n choose r is same as n choose n minus r, which is why 8 choose 1 is same as 8 choose 7. Okay, and what is 8 choose, or like okay, like 13 choose 13. Okay, so 13 choose 13. If there are 13 members in a squad, and my team is also supposed to be 13 members, how many ways can I select? Only one way. I literally have to select everyone. Okay, so it's again no surprise, it is 1. And what is little weird in understanding is 13 choose 0, right? 13 choose 13 is same as 13 choose 0. Okay, how do I make sense of it? So if I have to select 0 people from 13, I can do it in only one way. The act of not selecting anyone is one act, right? So that is that one. So 13 choose 13 is same as 13 choose 0, which is 1. So and the formula also will give us the same thing, right? What will the formula be? 13 factorial by 0 factorial into 13 factorial. Okay, and 0 factorial we know is 1. Okay, so okay, how do we know 0 factorial is 1? Okay, so that's some base that we start with, right? So you can start with 0 factorial. By convention, 0 factorial is set to be 1. 1 factorial, of course, is no problem. Anyway, like any number more than 1, we can go back all the way till 1 and multiply. For 0 factorial, to visualize that is difficult. We just go with a convention saying 0 factorial is accepted to be 1. That's it. Okay, so 13 choose 13. So any number, so or more generally, n choose 0 is same as n choose n, which is 1. And then n choose n minus 1 and n choose 1 will be same, right? This will be n. So these are two very common observations. Of course, we are not going to do if then choose 2, we know it's n into n minus 1 by 2. So the common ones are n choose 1, n choose 2, n choose 3, n choose 4 maximum, right? So you should be comfortable that the bottoms are 3 factorial, 4 factorial, and so on. Okay. Another important observation you should have is n choose R is same as n minus 1 choose R plus n minus 1 choose R minus 1. Okay. So, I mean, this is like plain, very formal like, right? But if you understand the intuition behind this, it'll be good, right? So I'll take a numerical example. It's much easier. Okay. So suppose I'll have to select 11 from 16. Okay. So I'll just literally write what the math is telling. So it's 15 choose 11 plus 15 choose 10. Okay. Now let's understand this numerical example. It's easier to understand. So I have a squad. So in any sport, you have a squad. Let's say it's cricket, right? So you have a squad of 16. But I'll have to select a team of 11. So I need to select a team of 11 because not everyone will be in the playing 11, right? So playing 11, they say in cricket, right? So it's a playing team of 11. Of the 16, I'll have to select 11. Okay. Now, there's one way to think of it, right? So let's say I'm the selector, and so these 16 people are standing in front of me. Right? So all of these 16 are standing in front of me. Okay. I'm the selector. I close my eyes. I randomly open and look at one particular person, right? With no bias, right? With no bias at all. This one particular person. And then I think in my mind, either this guy is in the team or this guy is not in the team. Okay. Now, if I select him in the team, that means my problem reduces to only selecting 10 more from the remaining 15, correct? So I'm looking at the number of ways in which I can form a team of 11. So 16 choose 11 is the left-hand side. That's clear, right? So I'm illustrating how I can arrive at the same number in 2 different ways. One is simple 16 choose 11 problem statement, very clear. 16 squad. I have to select a team of 11. That's 16 choose 11 ways in which I can do it. That's very clear. Okay. Sorry, Ananya, how am I going to call you to distinguish the two Ananyas? I'll call you Sharma. Is that okay? Ananya to me is the original Ananya. So the original Ananya will remain, and then I'll call you Sharma. Okay. Sharma, all clear so far? Making sense? Okay, cool. Right. I mean, others know, but since you joined recently, just stop me. Anyone for that matter, just stop me. And Shivank and Kunal, videos off, beta. Turn on the videos, please. I don't have to tell this. By now, you guys know. Video on throughout the class. Okay, so 16 choose 11 is the number of ways I can select. Now I'm arriving at the same 16 choose 11 in a different way, right? So in that different way, what I'm saying, I'm randomly opening my eye and then spotting one particular player. So let's say that player is here. And I think in my mind, either this player is in or not in the team. So if I've accepted that he's in, then my problem reduces to selecting only 10 more from the remaining 15. That's 15 choose 10. Or if I decide that that player is not going to be in, is not in, then my problem reduces to from the remaining 15, I'll have to select 11, right? So it's therefore I have only 2 options: either include him and select only 10 from the 15, or don't include him and select 11 from the 15. So which is why 16 choose 11 is 15 choose 11 plus 15 choose 10. Okay, does this make sense to everyone? Kunal, you're with me. Shivank, your video is still not on. Are you around? Or is just okay? All right, probably he's not around.
So I'm just having problems trying to fix it.
What problems?
So with my camera, it's not turning for some reason.
Okay. All right, please fix it.
Yeah.
Okay. All right. Now, so this is what you would see in the Fibonacci triangle as well. So Fibonacci triangles, many of you would have seen this. I start writing 1, 1, 1, 2, 1. I keep adding the numbers and put it in the middle, right? 1, 3, 3, 1. Okay. And these you should realize are the coefficients of, so this is like just a plus b, for example, right? And this is a plus b whole square. If you see the expansion of a plus b whole square, it's a square plus 2ab plus b square. That's where the coefficients 1, 2, 1 are coming. If it's a plus b whole cubed, it's just 1 second. I have something on my desk. I'll just have to wipe it. Okay, I'm back. Okay, so the coefficients in the Fibonacci, in the Pascal's triangle, I'm sorry, Pascal's, did I say Fibonacci earlier? Mistake. So Pascal's triangle, right? So Pascal's triangle, how do we get it? So we add this, and a plus b whole power 4 is this, right? So this is exactly coming from this. So for example, let's take a smaller number, right? So I'll put one more, a plus b whole power 5 will have the coefficients as 1, 5, 10, 10, 5, and 1, right? All of you understand this, right? I add two numbers and put the sum in between here. Okay, Sharma, you're with me? How I arrive at this Pascal's triangle? You've seen this Pascal's triangle before, right? Okay, now what I'm trying to illustrate is, let's pick one particular example. I'm saying this particular 10, right? Let's look at this triangle. I'm saying the 6 plus 4 is this 10, right? So what is this 10? The 10 that I have here is my of 5. I have to select 3. Okay, so that is same as 4 choose 2. This is my 6. So this is my 6, right? And then this is 4 choose 3. So that's how the Pascal's triangle work. If I add the 6 and 4, I get the 10. The 6 is, again, this is a reduced example of the 16 choose 11, right? Let's say the squad is 15 now, right? The squad is 5 now, and the team size is only 3. I'll have to select a team of 3. Then 5 choose 3 is the number of ways in which I can do it. I randomly look at one particular person, right? I say, okay, he is not in the team, which means I'll have to pick 3 people from the remaining 4. That's 4 choose 3. Or he's definitely in the team, which means from the remaining 4 people, I only have to pick 2, because I've already mentally picked this one random guy that I first saw, right? So I just want to illustrate how the terms in the Pascal's triangle come from this relation, right? Adding the 2 and then arrive at the next number. Okay, and in fact, all of these coefficients are also the binomial coefficients, right? So for example, the 6 is, why did we get 4 choose? Why did we get okay? Why did we get 5 choose 3 as the coefficient of, so coefficient of a cubed? So 5 choose 3 is 10. Okay, so a plus b whole power 5. Sorry, I'm just digressing a little bit. So a plus b whole power 5, the expansion is a power 5 plus the coefficients are 5 a power 4b, and then the next coefficient is 10 a cube b square. The next one is 10 a square b cube. The next one is 5 a b power 4, and the last one is 1 b power 5, right? So I'm talking about this 10 here. That's a coefficient of a square b cube. So what does that have to do with 5 choose 3? It has everything to do with 5 choose 3. Why is that? The term 5 choose 3 is because we have 5 set of a plus b, a plus b, a plus b, a plus b, a plus b. Okay. Now, if I'm looking at the coefficient of a square b cubed, right? For me to generate a square b cubed, I need to pick some 2 random a's and 3 b's. So it could be this a multiplying this b, multiplying this b, multiplying this a, multiplying this a. Okay, that's the 3 a's and 2 b's. Or in another day, it could have been this b multiplying this a, multiplying this a, multiplying this b, multiplying this a. So that's another way in which I can pick 2 b's and 3 b's and 2 a's. Or did I count the number of a's more and b's less? Okay, but you get the idea, right? So I'll have to pick 2 a's and 3 b's. I'll erase this. Maybe I did pick right or wrongly. Okay, let's do this one more time. So if I pick 2 a's, it could be this a with this a with this b with this b and this b. So that's 2 a's and 3 b's. Or another day, I could have picked this b and this b and this a and this a and this b. Okay, so I'm selecting 2 A's and 3 B's. If I select 2 A's, automatically from the remaining terms, I'm going to pick B's, right? Which is why the coefficient is 5 choose 3 or 5 choose 2. Both are same. If I choose the A's, automatically the B's are selected. If I choose the B's, automatically the A's are selected. Okay, so that's the coefficient 10. All of you with me? Kunal, you're with me? Understanding what I'm doing, talking, right?
Yes, sir.
Okay, cool. Okay. Now with that, let's start to do the probability. Let's start to do the homework questions, right? All of you hopefully attempted this homework. Let me bring it up here. What is that? One sec. Sharma, you also have the homework, right? I think I messaged you separately, or
I haven't gotten it.
you have it, right? Okay, cool. AMC10 homework 5. Okay, so I'll be doing variants of these questions as we discussed, right? So first one, list the different orders in which 4 people A, B, C, D could line up. That's very easy, right? That's 24 ways you can write them. You can write it in alphabetical order. Okay. Determine the probability that A sits next to C. Kunsh, what did you get on this one for the A part?
I got half the time. So.
Half. Okay. Can you just tell me why it's half? Yeah, Kunsh.
So
Expand,
because for any possibility it can be so. Hello? Hello, can you hear me, sir?
I can hear you.
Because you lagged out for a second. Yeah. For every possibility of A being next to C, there's another possibility where it isn't. So
Not very clear. What do you mean by that? So for example, so A and C can be here. Okay. So and then but it cannot be. So if it's
No,
this,
I got 1/4 in that.
okay, all right. So 1/4, 1/2. Okay. Any other answers?
So I also got half.
You also got half. Okay, let's discuss. Okay. So the total number of ways is 24. That's very clear. Okay. Now the favorable cases are where A and C are sitting next to each other, right? So the favorable cases. So let's say I have 4 slots here. Okay. Now, multiple ways to do this. Let's do what Kunsh was suggesting earlier. So he's saying for them to be success, it could be these 2 spots or these 2 spots or
I
these
got
2 spots.
20 by 3 for it.
Oh yeah, so it's half only because then you have to multiply it like CA is also there.
Okay. Okay. All right. I heard you. Kunal, what did you say? 20 by?
Probably wrong one.
No. I need to hear you loudly. I'm not very clear, Kunal. I mean,
Sorry, sir. I got 20 by 3.
20 by 3. It's a probability question, right? Answer has to be between 0 and 1. Hello? Am I audible?
Yeah, sure, but you're lagging quite a bit.
Okay. I don't know. Some internet issue on my building looks like today. I don't know. It was fine earlier in the afternoon. Sorry. What was this 20 by 3? I didn't understand. It's a probability, right? It has to be between 0 and 1, right, Kunal?
No, sir, I didn't say 20 by 3.
Yeah, which is why I heard you wrong. So what is it? Which is why you need to be clearer, louder.
Sorry, sir. Sorry.
No problem. Tell me, what did you say? 20 by?
20 by 3 times. It was 6 times. 24.
What is it?
Wait, sir. Let me. Wait, I did something wrong. 1 second.
Okay. Okay. 20 by at least this is meaningful, right? 20 by 24 is some number between 0 and 1. Okay. So let's discuss, right? So back to what Kunsh was saying. So if A and C have to be successive, it's the spots 1, 2, or the spots 2, 3, or the spots 3, 4. Okay. So there are 3 ways in which they can choose which 2 they can sit, which 2 consecutive work elections they sit. Once they decide, A and C can sit left, right, or right, left. So that's 2 ways. And the remaining 2 spots, B and D, can be either this way, that way, or that way, this way, right? So there are 2, right? Am I right? So that's 12 by 24, which is 1 by 2. Does it make sense? Okay, and the same can be extended. For example, instead of A, B, C, D, suppose I have E, F, and G. Okay, E, F, and G. Then I'll do the same logic, right? So instead of the first number, 1, 2, 3, 4, 5, 6, 7. Okay, so the starting seat for A and C to be together could be as left as here or as right as here. So there are 1, 2, 3, 4, 5, 6, 7 spots. So the starting location can either be 1 or 2 or 3 all the way till 6. So there are 6 locations for the start. And in each of those, A and C can sit either left, right, or right, left, which is 2. And the remaining 5 people in the class can sit in any 5 factorial way, right? So the equivalent of 3 is 6 here. The equivalent of 2 is still 2 here because left, right, or right, left. And then the equivalent of 2 factorial here, right? Which is 5 factorial, the remaining 5 people. Of the same, the equivalent denominator would be 7 factorial. Makes sense, right? Okay. Okay, let me ask this extension question before we go to, actually, let's discuss question B and then we'll come to this thing. Anahat, what did you get on part B? Exactly 1% between A and C.
4. 1 second. Let me just recheck. I think I got 4. Yeah.
You mean
Yeah.
4 on
No,
24?
sorry. 4 over 4 factorial. So 1 over 3 factorial, which is 1 over 6.
4 over 24, which is 1 over 6. Okay, all right. Anyone same answer?
So I got 1/4.
You got 1/4.
Yeah,
So
even
I
I got
originally
1/4.
got 1/6.
Oh, sorry, you also got 1/6 and someone else also
I
got 1/4.
originally got 1/6, but I think it will be 1/3, sir.
1/3 now.
1/3.
Because you can flip A and C, so I did not
Yes,
account
same.
for
I
that
got
earlier.
1/3.
So that's why I think it's 1/3.
Okay, let's discuss. Exactly 1% between A and C. We'll take the same approach. So there are 4 spots. So this, and this. Okay, so for A and C to have 1 spot in between, either they can be here and here, or they can be here and here. Okay, so there are only 2 sort of possibilities. And in each of them, they can sit left, right, or right, left. So 2 possibilities. And then once they have decided their positions, B and D can be either left, right, or right, left from the remaining positions. So it's this upon 24, which is 1/3. Make sense? Bihan, Anahat, how did you get 1/6 or 1/4?
I forgot to multiply the last 2. Actually, I didn't. realize the
Okay.
switch.
Okay, so that explains that. What about 1/4? Whoever called out 1/4? What was the mistake?
So I divided wrong.
You wrote it wrong.
Yes, sir.
Okay, all right. Sorry, I couldn't hear that. But okay, you wrote it wrong. Okay, cool. Now let's do an extension of this problem. Okay, so I'm going to give a part C. So part C is there are 7 people, A, B, C, D, E, F, G. Okay, and I'm going to ask what is the probability that B, D, and G are next to each other. Okay, can you guys take 1 minute to do this question? You can leave your answer in factorial terms, or you can give the numerical value. That's fine. With 7 factorial is not a big number, right? I mean, things will cancel off also. So you can give me a numerical answer, please. Yeah. No calculator, just hand.
So what is G?
A, B, C, D, E, F, G. I've changed the problem.
Oh,
to, there
okay.
are 7 people now. A, B, C, D, E, F, G. And then I want B, D, and G are next to each other. Probability uska. Okay, B, D, G are together, let's say. Okay, they can be in any order, but they are together.
3 factorial into 5 factorial.
3 factorial into 5 factorial. You mean upon 7 factorial, you mean?
Yeah, upon 7 factorial.
Okay, okay, all right. Any other answers?
So I'm getting 1/7.
Okay, so you're getting 1/7. Okay,
I'm
So-
also getting 1/7.
1/7. Okay, all right. Ananya, can you tell me why 1/7?
There's 5 places the first person could be.
Okay, so basically you're saying the starting can be, so they can occupy these 3 spots, and then Again, they can go all the way till here. So there are 5 possibilities for the starting location. Okay,
And there's 3 factorial ways in which they can be arranged.
correct.
And there's a 4 factorial ways in which the rest of the numbers could be arranged.
Exactly. Okay, upon 7 factorial. And this is exactly what Anahat also said, right? So he said there are 3 factorial ways. So let's see whether this simplifies to 1 by 7. And then I'll explain his answer also, right? So, oops, I don't know why this scratch went all the way till here. Okay, all right. So everyone clear on what her explanation, right? So let's simplify this. So this is, by the way, 5 into 4 factorial is indeed 5 factorial.
So why did you multiply by 4 factorial at the end?
Because the remaining 4 can sit in 4 factorial ways, right? For the remaining 4. Okay,
Yeah.
makes sense, right? So let's say this B, D, and G. Understood, right?
It doesn't matter like how they are.
Let's say B, D, and G decide to sit somewhere here. Okay, right? Yeah, and yeah, it does not matter. But yes, I have to count all the ways in which they can sit, right? If I'm dividing by 7 factorial, I'll have to do that, right?
Yeah.
Okay, so first of all, we see that 3 factorial, I'm retaining common. 5 into 4 factorial is same as 5 factorial, right? Okay, now 5 factorial will cancel with 6 factorial, giving 6 and 7. And therefore, this reduces to 1 by 7. Okay. All right. Yeah, in fact, I was going to say, what is the probability that B, D, G are not together? So that'll be just 1 minus this, right? So the question initially was, what is the probability that B, D, G are not together? That could mean by B and D are together, but G is away. Or it could mean that all of them are away, as in they have caps in between. All of those possibilities are accounted by doing 1 minus the probability that they are together. So if the question is, what is the probability that B, D, G are not all together? That means it's 1 minus the probability that they are together. Okay, all right, let's move to question 2. Coin is tossed. Okay, so the first. Okay, so the first 2 parts are fairly easy. Let's go to the third one. What is the probability of getting a tail or a vowel or both? Kunsh, what did you get on this one? For the C part. Yeah,
So
Kunsh.
for this one,
Is it me or him now? Looks like him.
It's him.
Okay. Avinash, what did you get? On 2C.
So I got 7 upon 8.
7 upon 8. Okay. Any other answers? Ananya, did you get the same?
So I couldn't do this one.
I got 5 by 8.
5 by 8. Okay. All right. Okay, let's discuss. So tail or vowel or both. Okay. So this means it's probability of tail union vowel. Correct? Either tail or vowel or both. So by Venn diagram, whatever works for Venn diagram, same works for probability. So it's probability of getting a tail plus probability of getting a vowel minus probability of getting both, right? Because you have to subtract that because maybe you added it instead. That's
Yes,
why
I
you got-
added it. I didn't subtract it.
Okay, so that explains. So probability of getting a tail is 1 by 2. Probability of getting a vowel is 1 by 4. And the probability of getting both is 1/8. Right? And why is that 1/8? Because it's half into 1/4. And why is it product? Because if there are 2 independent events happening, then the probabilities will multiply for both events to happen. For example, what is the probability that, okay, in fact, this itself, what is the probability that coin is tail and you're picking a vowel, right? This is not going to influence that, right? And therefore, the probabilities will multiply. So where will they not multiply? So for example, in fact, I'll give another one for independence. What is the probability that it's raining in Mumbai and Sydney at the same time, right? That's probability that it's raining in Mumbai times the probability it's raining in Sydney. Because the weather in Mumbai is not going to influence the weather in Sydney by any stretch of imagination, right? Maybe by some stretch of imagination. Okay, but however, suppose I ask, what is the probability it's raining in Mumbai intersection, let's say Thane, right? Then this would be wrong to say, right? Because if it's raining in Mumbai, very likely it's going to rain in Thane as well, right? So they are not independent events, right? So it won't be the product of Mumbai times Thane, right? So the
What would it be
intersection,
so then?
yeah. So you will need to be given more information. That's all we can say. It won't be the product. It'll be higher than the product, or it depends on the correlation, right? It should generally be higher, right? Because just imagine, let's say it's rainy season, right? Just for example, if someone has to ask you to guess a probability that it's raining in Mumbai on any given day, let's say you are in a prison, you don't have any track of time, you don't know what year, what month, what day chal raha hai, kuch bhi nahi. You're being asked what is the probability right now outside in the world it's raining. Then you'll take a guess. Roughly 3 months it rains in Mumbai. So 3 out of 12. So I'll say 1/4 is the probability that it's raining in Mumbai at any given time, right? And similarly, if the question is for Thane, again same weather, you'll say 1/4. But if you do the product, it'll seem like 1/4 times 1/4, which is 1/16, right? Which is very small, because again, you're in the same prison, you're being asked what is the probability it's raining in Mumbai and Thane, right? So 1/16 is very unlikely, because if it's either June, July, August, or whatever, right? July, August, September, whatever, it's very likely to rain both in Mumbai and Thane simultaneously. So still the probability will be close to 1/4, but probably slightly less than 1/4. Maybe it's still sunny in Mumbai, but rainy in Thane, or occasionally it could be sunny in both, or it could be raining in Thane, but not in this thing. But very likely it's raining in both places simultaneously. So the probability will be slightly less than 1/4. Maybe it's 1/5 or 1/6, but definitely not as low as 1/16. Does it make sense? Right? Yeah, logically it makes sense, right? And to your point, how do I find that out? You cannot immediately find this out. You need to be given something called correlation and all that to find out, right? But it's enough to know that you cannot find out with just this information. But most of the problems that you are dealing with is going to be independent, which is why you keep saying an independent experiment. That way you can safely multiply the probabilities. Okay, all right, that was that question. Sharma, all okay so far? Any doubts?
I haven't done the first question which you. So I was a little confused.
Which one? The first question in the homework that we discussed. So obviously would not have done the homework itself, because I sent it only yesterday or something to your mom. You can, or from the discussion you did not understand?
The three variables that you multiply, what would it be? The first one. So you were saying this or that, but I'm not sure what you meant.
Sorry, for which question? For the coin one or the?
For the first one.
For the first one, list the different orders in which A, B, C, D, E, F, G would line up. That one?
Yeah.
Okay. So you mean the 2 times 2 times 2 by 24? Is that what you meant?
Yeah.
Oh, okay. All right. No problem. Right. I'll just quickly explain this. Right. So for the B part, right? Was for the B part, exactly 1% between A and C for that one, right?
Yeah.
Okay. So yeah, you can stop me in between itself. That way it's easier than wait till like later, right? Okay. So all I'm saying is there are 4 spots. Okay. So we are asking what is the probability that one person is sitting between A and C. Okay. So for one person to sit in A and C, either A and C have to choose to sit in first and the third spot, or they can choose to sit in the second and the fourth spot. You're with me so far? Yeah, Sharma?
Yeah.
Okay, for one person to sit in between. So there are 2 ways that way, that they can be in 1-3 or 2-4 position. So that's the 2. Having done that, having chosen that these are our 2 spots, they can decide who will be 1 and who will be 3, right? Or who will be 1, who will be 2, who will be 4. Whatever 2 they select, they can either be left, right, or right, left. So that's 2 further possibilities, right? I'm multiplying all the different things. It's like, let's say you have 3 shirts and 4 pants and 2 ties. How many ways can you dress up? It's 3 into 4 into 2, because with everything I can mix and have the other set as well, right? And now automatically the remaining 2 spots are for B and D. They also can sit either left and right or right and left for the remaining 2 spots. That's the 2 of the 24. Just 1 second. Excuse me. Okay, makes sense?
Yeah.
Okay, yeah. So question 3. probability that the man will
So-
be alive. Yeah.
I still don't understand why you have to minus it. So I lied out when you were explaining that. Why is it minus 1/8?
Oh, for this one. Oh, okay,
Yeah.
okay. That's same as set theory. Forget probability, right? How will we do? Okay, so how will we do? Forget this problem, right? So let's say I have another problem where I have a set A and set B. Okay, so let's say this is the people who learn whatever maths, and this is the people who learn physics, and there are some people who learn both, which is the intersection, right? So let's say there are 20 people here who are learning math, and 30 people here learning physics, and there are 5 people who are common, which means there are 15 here and 25 here who are learning only maths or only physics respectively. Do you agree with the numbers here
Yeah.
so far? Now, if I'm asking what is the total class strength, we know that it is the 20 which is in math plus the 30 which is physics minus the 5 which are being double counted, right? The subtraction
Right.
5 is the double counting. That's
Right, sir.
exactly what I'm doing in probability also here,
Oh, all right.
right? So it's one way to count it as
Yeah.
20 plus 30 minus 5, or you can do only maths, only physics, and then count both. That's also possible. But this is a little harder, right? How in the tail probability, in the tail and this thing probability, right? We can still do that. In fact, given that you asked this, let's do this, right? So we understand half plus 1/4 plus 1/8. Let's do it in another way. We'll say it should also be the probability that's only tail, only vowel, or both. Let's do that and see whether we get the same 5/8. Okay, so let's do that now. So only tail. I'll erase this and make some space here. Only tail means what? I should get a tail and I should get a consonant. So probability of only tail, okay, means I should get a tail and a consonant, correct? That combination, which means it's half for getting the tail and 3/4 for getting a consonant, which is 3/8. Okay, now what is the probability of only vowel? Only vowel means what? I should get a head and I should get a vowel, which means half for getting a head and 1/4 for getting a vowel, which is 1/8. And what is the probability of both tail and a vowel? So which means I should get a tail and get a vowel, which is something which you already did. It's half into 1/4, which is 1/8. Now I can add all of them. 3/8 and 1/8 and 1/8 add up to 5/8, which is the same 5/8 that I arrived by doing this. Those are the two methods, right? Does it make sense? Yeah, Kunsh, you're okay?
Yeah.
Okay, everyone okay, right?
So, but in this question, how will we do if it's only tail, only vowel, but not both?
Oh, okay. So it's okay, only tail, only vowel, or not both, right? So it'll just be 3/8 and 1/8, right? In that case, it's only tail but not vowel, or only vowel but not tail. Okay. Again, depending on the question. So it's okay. So the question you're asking is, let's say I'll mark it as C2. Only tail. Okay, if only I can write neater. Sorry. So because depending on the wording of the question, it can the values can differ, right? So you're saying your question is only tail or vowel, but not both. Okay, so that will be exactly 3/8 plus 1/8. You won't subtract or add the remaining 1/8. Doesn't matter. So it's 3/8 plus 1/8. On the other hand, I could frame another question. It could be what is the probability that tail and vowel don't occur together? Don't occur together. Which means it can be only tail, or it can be only vowel, or it can be neither. Right? What is the probability that tail and vowel don't occur together? Means they both may not occur. That's also fine. But if one occurs, the other should not occur. Let's say they are enemies. So the easier way to do this is we can do what is the probability that tail and vowel do occur, and then do 1 minus that. So the probability for the one I'm stating here, the latest one, is 1 minus the probability that both occur, which is 1/8. Therefore, it will be 7/8 in that case. Does it make sense? So always pay attention to how the question is about it. Sharma, you're okay with all the possibilities here? Everyone, right? Avinash, you're okay? Okay, all right. Probability the man is alive, 3/5. Women is a wife is alive, 2/3. Okay, so this I think we can quickly do, right? Both will be alive, will be the product. So 3/5 into 2/3. Yeah, at least one will be alive. Yeah, at least one will be alive. Sorry, what did you get?
13 by 15.
13 by 15. Same
Yeah.
answer. Okay, we can do 1 minus probability that both are dead. So it'll be 2/5 for the man to be dead and 1/3 for this. So it's, yeah, indeed, it's 1 minus 2 by 15, 13 by 15. Only the wife will be alive. So which means the wife has to be alive and the husband should not be alive. So it's 2/3 into 2/5, which is 4/15. Fairly simple. Okay, question 4. Question 4. Okay, all right. So 4, I might not do all the parts. I'll just do the C part. Okay. So group of 40 students, 22 study economics, similar to that math and physics example I gave. So the last probability is find the probability that a randomly chosen student studies economics given he or she studies law. This is called conditional probability. So conditional probability is nothing but you're given some extra information. Now can you answer? So it's like asking, what is the probability that it's going to rain given it is murky, right? So this will obviously be greater than what is the probability. If you just ask what is the probability is going to rain today, right? Again, I'm in the prison. I have no idea. If suddenly I'm asked, like I'm totally disconnected from the world, what's the probability going to be rain? I have no idea. I'll just say again the same, whatever example, 1/4, I'm in Mumbai, let's say, right? But if I'm saying what is the probability, okay, I'll tell you that it's murky. Now tell me what is the probability it's going to rain to you. I'll say it's a very high probability. I'll say it's probably 8 by 9, something, right? I'll make up some number, but which is close to 1, very likely to rain given it's murky. Okay, so this is conditional probability. So how do I define conditional probability? So it's probability that is raining rain given murky is probability that it's rain and murky, but you divide by the probability that's murky. Okay, so this is denoted as R given M. I'll just say R given M. R given, it's like your division sign, right? R given M, which means what? You already know M has occurred. It's already murky, you know. Therefore, you divide by it. So which means the probability is going to be higher. So now what's the probability? It'll be rain and murky given it's murky. So it's divided by murkiness. So using that, let's do the C part. Anyone has an answer for C?
Sir, it's 2/5.
2/5. Okay. Anyone agree or disagree? Anahat, what did you get?
So I got 3/5, but I'll just check if I made a calculation error.
Okay. All right. 2/5, 3/5. Anyone else? Okay. Let's draw the diagram, right? So.
Oh wait, so I made a calculation error. I also got 2/5.
Okay. Good. Kunal, what did you say?
I'm not like I got 2 answers.
Fine. Call it out. It's fine.
I got 2/5 and I got 5 by 11.
5 by 11. Okay. All right. Let's discuss. Okay. So this is 40 students. So 22 study economics. So let's say this is economics and this is, which is the other one, law. Okay. This is 22. So this is 22 and this is how much? 25. Okay. And this entire class is 40. So 40 is here. Big box. All of you know Venn diagram. So I think, so this is a full class of 40. Now 3 people study neither. So the 3 is outside here, which means collectively these 2 should add up to 37, right? So this should add up to 37 total. So which means we know that, let's say the commonality is X here. So 22 plus 25 minus X should be the 37, right? So we can use this to solve X. So X is 47 minus 37, which is 10. So we know there are 10 which are common. So I'll erase this and replace it with 10. Okay. So I'll erase this and replace, this is 10, right? So 10 are common, which means this is now 12 and this is now 15. Let's add up again. 12 plus 10 plus 15 is indeed 37 plus 3 is 40. So now we are good with the Venn diagram. Now we can answer any question. Now, what is the probability for economics? So the probability that's being asked is probability that it's economics given law. Okay, so which means what? I'm telling you, it's one of the 25 students who are studying law. Now you tell me what is the probability he's studying economics. So which means it has to be the fraction 10 of the 25 people, right? The 10 who are studying both, right? It's probability of economics, intersection law by probability of law. So it's 10 by 25, which is 2/5 indeed. Does it make sense? So what is the 3 by 11? Sorry, 5 by 11, Kunal, what was that answer? How did you get that one? Or not worth discussing?
Yeah, so I think what I did is that first when I was doing 2 by 5, I took 10 by 25.
Yeah.
And then for the second one, I did 10 by 22. I was trying to figure out like how did I get different answers.
Okay.
Then I didn't realize that the
Okay. Okay.
numbers-
All right. A silly mistake, right? That's good. Okay. So now we understand it's 10 by 25. Okay. Let me ask a question now, extension of this. So I'll erase this. I'll say, what is the, let me illustrate, let me delete all the clutter. Okay, I'll leave this alone. So I'm going to ask a D question. A D question is going to be, what is the probability that random choose surgeons, okay, I'll say does not study, not studies, but does not study. So till here you can read the question as was, does not study law, given he does not study economics. Okay, can you do this one quickly? 30 seconds. Sharma, I'll be looking for an answer from you on this.
So I think that so won't it be one?
Okay, if it is one, it's one. Tell me why is it one?
So because if
Sorry, who's answering this? I asked Ananya Sharma to answer this.
oh, sorry.
Yeah, I said Sharma, so which means her. Yeah.
Will it be 1 minus 10 upon 25?
Okay, the 10 upon 25 was the previous, where it's economics given law. Now I'm saying it's not studying law given not studying economics.
But if that is both, then the next one is, you said 1 minus.
See, 1 minus would be, for example, probability that some event is happening is X. The probability that the event is not happening is 1 minus X. So what will be 1 minus 2 by 5 would be the answer to the question. The chosen student does not study economics, given he or studies law. That will be the probability, that will be 1 minus 2 by 5. Exact negative of that question would be 1 minus that answer. So the original question C read, what is the probability the chosen student studies economics, given he or she studies law, right? The exact opposite of that is chosen student does not study economics, given he studies law, right? That'll be the 1 minus 2 by 5, which is 3 by 5. But in this case, it's intertwined, right? It does not study law, given he does not study economics. Okay. Ananya, the first Ananya, right? Why do you say it's 1? It may be 1. Just tell me why it's 1.
So because there are three. I mean,
Louder, Ananya, please. There are 3 what?
so if a student doesn't study law,
Yeah.
economics, other than 3 students, all of them study law. So there's only 3 students who don't study economics and law.
So you're saying it's 3 over 3. That's
Yes.
why it's 1.
Yeah.
No, but the people. So first of all, let's write it. Like what is the question? Does not study law. So typically in probability or set, when you say does not or the opposite, it's L dash. L dash means not law, right? Or sometimes people use L bar. So this is same as the opposite of L, right? This means it's opposite of L, right? So the question says probability does not study law, given does not study economics. This is what we want, correct? So which means it's the probability that you're neither studying law nor economics, given, I'll erase what is written here, okay, given you're not studying economics. Agreed? Now, what is the probability you're not studying economics? It's not 3, but or 3 over 40, but it's rather economics is 22 people, right? As long as you are anyone from the remaining 18, so this economics bucket is 22 people. So as long as you are the remaining 40 minus 22, 18 out of 40 is the probability that some random guy is not studying economics. Of this, people who are neither studying economics nor law is 3 upon 40. Sorry, 3 upon 40. The numerator is 3 upon 40. And therefore, the resulting answer is 3 upon 18, which is 1/6. Does this make sense to everyone? Avinash, you're with me?
Wait, so I don't understand. Why can't we just say
Yes, sir. I
3 by
got the
40?
same answer.
Okay, good, Avinash. Okay, Kunal, what did you say?
So like, why can't it just be 3 by 40? Because that's 3 nice study neither. So
Because the question is not asking what is the probability it does not study law or economics. Then it will be 3 upon 40. I'm giving you extra information. Given he is not studying economics, what is the probability he is not studying law? Right? I'm telling you he's not studying economics. So which means the set is reduced already. Now you only have to say among this reduced set of 18 people, how many are not studying
okay.
right? Does it make sense?
Yeah.
Right?
Yeah.
All of you clear on this, right? It's very important, guys. Sharma, are you okay on this one?
Yeah.
Okay. Everyone, right? Shivank, you're hearing, right?
Yeah.
Even though your video is off.
Yeah.
Okay. All right. So that's conditional. Okay. Let's do the next one, right? So I think this next one also will illustrate the conditional probability well. Question 5. Okay. Probability of particular salesman will leave his glasses behind in any store is 1/5. Suppose the salesman visits 2 stores in succession and leaves his sunglasses behind in one of them. What is the probability that he left his sunglasses in the first store? So, okay, just so that we can just visualize this, right? So let's say you're an observer, right? So this guy, this professor, salesman, whatever, right? He's visiting a mall. Okay. So this is the mall. Okay. So you are outside here. So you are standing here and observing. So this guy enters with a specs. So he's wearing a specs. Let's say this is specs. Right? And then you see him enter with the specs, and then when you see him come out, he's not wearing a specs. All right? So this I'll color the specs in a different color. This blue is the specs he's wearing, but when you see him walk out of the building, is not with specs. And there are 2 stores here. What happened inside, you don't know, because the mall is all closed, right? From outside. You only make an observation that he's wearing a specs here and is not wearing a specs here. Now the question you're asking yourself is, what is the probability that he left his sunglasses in the first store? Let's say this is A and this is B. Okay. He could have forgotten in A, or he might have not forgotten in A, but forgot in B. These are the 2 possibilities, right? And potentially if there are more stores in another question, he could have forgotten anywhere. Now he's coming out, and now you're asking this question, right? The question is, the setup is clear to everyone at least? Anahat, you were missing in action for some time. All okay?
Yeah.
Were you there for the conditional probability, Anahat?
The fourth one, no, but it's fine. I got that.
But you understand the conditional
Yeah, I
probability
understood
concept,
the
right?
concept.
Okay, cool. Did you get an answer on this one, Anahat, on question? The salesman question, the glasses, question 5.
I did, but it's definitely wrong. It's
Okay,
it was very
Here
weird.
I got 1/2.
1/2.
I
Okay.
also got 1/2, but I don't think that's right.
Okay, let's analyze 1/2 for a second. Okay, let me ask this question, guys. Suppose instead of 2 stores, let's say the mall has 10 stores. A, B, C, D, E, F, G, H. Kitna tak jayega? H is 8. I, J, right? There are 10 stores in the mall. The same scenario happens. You see the professor going with the specs inside. He's wearing a specs, right? And then when he comes outside, he does not have a specs. Suppose I ask you to compare what is, given that you saw him come out without specs, according to you, Kunal or Anahat, right? It'll be 1/10 for everything.
Yeah.
1/10. But do you really think it'll be 1/10 for all of them? he's more likely to have lost in store A, right? Because for him to lose in store J, he must have not lost in A, not lost in B, not lost in C, not lost in D, and so on. And only after he has not lost in all the way till I, he can even afford to lose it in J. Whereas in the store A, he does not have any dependence. He could have right there lost it. So the probability will be higher for him to lose in store A than to lose in store J. Do you agree intuitively? And therefore, the expected answer here will be more, right? These two will add up to 1, that's for sure. But maybe it's more like 60% here and 40% here, right? I'm asking you to find out the exact number. It's maybe not 60-40, but something higher number for A and lower number for B. Is this intuition clear to everyone? Both Ananyas, all of you okay? Avinash, you're okay on the intuition? Intuition is very
Yes,
important,
sir.
guys, right? You should have a... Bolo.
I got
Avinash.
an answer. I'm not sure if it's correct.
Call it out.
2 by 20,
2 by
25.
2 by 25. After saying you got the intuition, you're telling me an answer which is less than half. At least his
That's
answer was
okay.
half.
Yeah. No, there was some issue. I multiplied it in some wrong way.
Okay,
That's
all
why.
right. So you agree that it's obviously wrong, right? That's all matters. Right? Do you agree it's obviously wrong? Because
Yeah.
if this is 2 by 25, then probability of him losing in B is 23 by 25, right? First of all, it's very distorted. The answer should be fairly close, right? I mean, at least if not close, we know for sure now that probability of losing in A is higher. Excuse me, I'm sorry. Okay, work it out, guys. I'll give you, now that you know conditional probability, I'll give you all a minute to work this out.
So I got 7 by 10.
7 by 10. Okay. All right. Which means by implication for him to lose in store B is 3 by 10. Okay. At least this seems reasonable. I'm not saying it's right. At least it's reasonable. 7 by 3 is greater than 3 by 10. And 7 by 10 plus 3 by 10 is adding up to 1. Okay.
Yes,
Any
I
other?
got 7 by 10 as well.
Okay. Should we discuss or people want 30 seconds more to try?
I got 8 by 10.
8 by 10. 8 by 10 and 2 by 10. That means. Okay. Let's discuss. Okay. So what's going to happen here? So this guy entered. So this is store A. He first entered. So I'll say forget is F. So he forgot, right? I'll just say he forgot, or what's the other word I can say? He remembered how he still has this classes. Oh my God, this is very difficult. What letter should I use to say he still has glasses? Okay, G. He still has glass. F means he forgot his glass. Okay, R for remember. Okay, fine. Whatever works. Okay, now what am I saying? So he has just entered. So this is in store A, right? So in store A, with a probability 1/5, he forgot. And with a probability 4/5, he still has this. So this is store A, right? Whatever I'm describing here is store A. Now store B is going to come. If he forgot, then obviously he's lost his glasses automatically. So with one probability at the end state, he still does not have his glasses. Right? He does not have his glasses. Right? So he's lost his glasses. In fact, I'll just use the word L. Right? L means he's lost his glasses. So he's continued to be in the lost state. He's already lost. There's nothing more for him to lose. At the end state, he's still lost with one probability. Right? He's already lost it. Whereas if he still has his glass, then from here on, he can lose with a probability of 1/5, or he can have a good day and he can still retain his glasses with G. Is this picture clear to everyone? Now, we are told that he came out forgetting, which means we know for sure that he is either here or here. Right? Which means one of the two paths has occurred, which means either he has come this way and this way, or he has come this way and this way. Right? That's how he has arrived either here or he has arrived here. But we know for sure he has lost it for sure. Okay. So first of all, what is the probability of him losing? Let's
Sir, sorry, I want to change my answer. It's 5 by 9. I messed
5
up.
by 9. Okay, all right. So 5 by 9. I'll write that as here 5 by 9 and 4 by 9. Okay, right. So what is the probability that he's lost it? So it's 1/5 into 1/5 following the red path, or it's 4/5 into 1/5 following the turquoise path, right? So how much is this? This is, am I right? 4/5 into 1/5. Okay. 1/5 into 1. Sorry, not 1/5 into 1/5, but 1/5 into 1. We said the other one is 1, right? 1/5 into 1. So 1/5 into 5/5, in other words. So I can say this is 5 plus 4 by 25, which is 9 by 25. So for him to lose, it's 9 by 25. But now, what are we asking? What is the probability that he lost it in B, given he lost it? Right? So which means it's asking what is the probability of one. So okay, just to write out formalically, what does it mean? What is the probability that he lost it in B intersection lost? Okay, so forget the notation. Okay, so you understand that the question is, what is the probability that he lost it in B, store B, given he lost it? Which means we'll have to see what fraction the latter root, the 4/5 into 1/5 contributed of the total probability of 9/10, 9 by 25, right? The total probability was 9 by 25, right? For him losing, of which one fraction came from him losing in store B. That was 4 by 25. So the answer is 4 by 9. So 4 by 9 is the probability that he lost it in B. Oh, what is the question? Probability he left it in lost it in the first store. So it'll be the other fraction, right? So it'll be 5 by 9. Yeah, you're right, Anahat. Okay, so if you have to do it separately, so what is the probability that he lost it in A, given he lost it, which means it's the path that we first took, right? It's 1/5 of into 1 of the total 9 by 25. So that's 5 over 25 out of 9 over 25, which is 5 over 9. Do both these answers make sense? And clearly 5 by 9 is more than 4 by 9. He had a higher probability of having lost in the store A compared to store B. Does this make sense to everyone? Okay, all of you okay on this one? Vihan?
Yeah.
Yeah, okay. I'll ask another question, right? Okay, so I'll make up a question. Okay, all right. So there is a basket. There's a basket. Okay, the basket has 3 reds and let's say 4 blue. 4 blue balls, let's say. So 3 red balls and 4 blue balls. Okay. Now, you don't get to see the balls at all. Let's say you're blindfolded. Okay. Now, you're asked to pick one ball from here. Okay, you're still blindfolded. Okay, and then you cannot see that ball. You have to just throw it out of the window. You don't know what that color was. You just threw it out of the window. You're still blindfolded. Now you're asked to pick one more ball. Okay, now you observe it's red. Okay, now your putty is taken off. See that the second ball that you picked is red. You can visually see this. Now my question is, what is the probability that the first one was blue? The first one was blue, given the second one that you just observed was red, right? So the illustration is clear, right? What I'm saying, the second one is red, and now I'm asking you, what is the probability the first one was blue? It's conditional probability, right? The ball that you threw out of the window, which you did not see, right? I'm asking you, what is the probability that was blue? Okay, can you all attempt this question, please? Is the question not clear? Ask right away rather than wait for long. If the question is very clear, get going. I'll be back. I'll just get something to eat quickly. Okay, but I'll
So
give
is there replacement or no replacement?
no. Are Bapa, I told you, right? I chucked it out of the window.
Okay.
Okay, so things will not be spelled explicitly with replacement, without replacement. Bola nahi jayega. You have to figure out. Obviously, it's without replacement. You've chucked it out of the window. Okay, I'm back, guys. Anyone with an answer? It's okay. Even if you're not confident, just call it out. It's fine. We'll discuss anyway. Go ahead, please. Bihan, come on.
So I'm still doing it.
Okay. Anahat, anything from you? Why does Anahat leave the class every now and then? I don't see him now. Okay. Shivank, very quiet. Bolo.
So I've still not got an answer.
So I got 2/3.
2 by 3. Okay. Or I'll write her answer here, Ananya's answer. What about Sharma? Do you have an answer, Sharma?
Not sure.
Okay. All right. How long should we discuss, or someone is asking me to hold? I'll hold. Okay. No one is asking me to hold, which means we'll discuss. Okay. All right. So let's draw a diagram. Okay. So so the first ball could have been red with a I'm not going to keep changing the font color. So I'll just, so it's 3 with 3 by 7 probability, it could have been red, right? With 4 by 7 probability, it could have been a blue. So this is the starting state, right? So I'm in the starting state, right? Suppose I picked a red, then how many? So the starting state is 3 red and 4 blue. Okay. So with 3/7 probability, I'll end up losing a red, right? So this is the red ball, but I don't know, right? My eyes are still blindfolded, right? So with 3/7 probability, I picked a red, and with 4/7 probability, I picked a blue, which means I would have landed up in 3 red and 3 blue, right? So from here on, when I picked the second ball with 2/6 probability, it should have been red, right? 1 red and 4 blue. Or with 4/6 probability, it should have been a blue ball. So it would have been 2 red and 3 blue. Likewise, if I'm in this state with half probability and half probability, I would have ended up being 2 reds, 3 blues, or 3 reds, 2 blues. Now, I'm told that the second one is red, which means I'm told that it's either landed here or landed here, right? Right. Okay. See, that's red. First one is blue, given that is. Okay. So what is the question? First one is blue, given the second one was red, right? Second one was red. Second one was red. Yeah. Okay, draw this. And then the second one was red. Observe it. Okay. Maybe I stated the question. Okay. So you observe that the second one is red. And what is the probability? So yeah, no, it's all fine. Now, what is the count within the box? You don't know, right? Just to be very clear, we don't know. When I say you are in this state or in this state, I mean that you still don't know what state it is in the box. It could have been either the upper wala state or the niche wala state, because you don't have visibility to see in the box. If you see in the box, then you can conclude something, right? You only know that the second ball that you have picked is red. That's all you know. Okay. So all of it clear so far? Now, which means we could have taken either this path to arrive. So you could have come this way and this way, or you could have come this way and this way. Sorry. Yeah, correct. This way and this way, right? Right? Because you have arrived at a case where the second one is red. All of you okay on this one so far? Okay. So in fact, what will this probability be? What is the probability that the first is blue and second is red, divided by probability that second is red? That's what the definition of conditional probability was. Sharma, are you with me completely? Okay, now let's do the denominator first. What is the probability the second was red? It's the combination of both of these parts, right? It's 3/7 into 2/6 because you wanted the first one to be red and the second one to be red, or you wanted the first one, the lower path is the first one was blue, which is the 4/7, and the next one was red, 4/7 into 3/6. Okay, so maybe I'll just use a neutral color in when I'm writing this, right? Otherwise, you might conclude like, okay, so it's the upper path, which is 3/7 into 2/6, plus the niche path, which is 4/7 into 3/6. Of this, I need the contribution from the which path? The first one is blue, right? The niche wala path. So 4/7 into 3/6 as a fraction of the total, because that's the path where the first one was blue. Is this clear, guys? Vihan, are you with me?
Yeah, sure.
Okay, now the 7 into 6 is everywhere 7 into 6. I won't even bother cancelling. I won't even bother internally cancelling each of them. So it's 12 upar upon 6 plus 12, which is indeed 12 over 18, which is 2 over 3. Excellently done, Ananya. You said 2/3, right? Is this exactly what you did? Okay. Does it make sense to everyone, guys? Avinash, you're okay? Sharma,
Yes.
you're okay? Kunal, Kunsh?
Yes.
Okay, cool. Let's move on. That was question 5 and some extra problem. Question 6. A team of 5 is randomly chosen. Determine the probability that all are doctors. Yeah. If people have not done it, you can just quickly do it now also. Or you can tell it in terms of choosing also. Even if you don't have the numerical number, that's fine. Avinash, do you have an answer?
So I got 5/6. No, sorry, wait. I got 3/5.
3/5. Okay, anyone agree or disagree? Kunal, what did you get? Kunsh, what did you get?
Sir, I got 3/5, but then I changed it to 2/5. sir.
Okay, all right. Kunal always has trouble with 3/5 and 2/5. Second time today. Kunsh, what did you get?
So I also got 3/5.
Okay, all right, let's do. So 6 doctors and 4 dentists. So there are 6 doctors and 4, I'll call dentists with a T, because D and D becomes confusing, right? So there are 10 people essentially. What's the probability that the team of 5 that I select is all doctors? Which means my total cases are of 10 people. I don't view them differently. I have to select 5. That's the total cases. No restriction at all. 10 people, I have to select 5. Now, if I have to select all doctors, that means I'm selecting the 5 from the 6, right? Or in other words, yeah, I'm selecting, and then from the or to be very explicit, and I'm selecting 0 from the 4. To be very explicit, I'm selecting 5 from the 6 doctors. I'm selecting 0 from the 4 dentists. So it's a product of this. But 4 choose 0 is 1, as we saw, right? Anything choose 0 is 1. So which is why it's okay to leave it out. So let's see whether this simplifies to 3/5. Very unlikely. I don't think they'll simplify to 3/5 or 2/5 in fact. Let's see. What is 6 choose 5? Same as 6 choose 1, which is 6. Right? And what is 10 choose 5 in the denominator? It's 10 into 9 into 8 into 7 into
252, right?
6 by what did he say? 252, is it? Okay, all right, let's check.
Yeah.
By
I
5
think
factorial. By 5 factorial is 120. 5 divide by 120 will go upper, right? 120. So 120 cancels. 12 cancels 6 times. All right. So yeah, it's 6 by, yeah, what you said is for the denominator is right. It's 36 into 7, which will be 252. But anyway, I don't have to do that. I'll just say 1 upon 42 is the answer. Does it make sense? Neither 3/5 or 2/5. All of you clear on this one method?
Yes.
Okay, now can you do the second part at least, guys? Now that you know a little bit more about choosing and arranging and all that, I'll give some time to do. All of you do the question 2. Question B.
1/42.
1 by 42. Yeah.
Oh,
What, you got that?
no, I got 2/5.
I know. But I thought you did get that, but you thought it's too low and then you erased it, something like that, Karki. Yeah, the reaction you gave was like that.
very different from like what I got. So
Yeah. But does this make sense, guys?
yeah,
I'm not pulling it out of air, right? It's what logical. Okay. B part, at least 2 doctors. Okay, how's it going, guys? Should we discuss or need more time? I'll erase all this clutter.
So I got 5/21, but I don't think it's right.
5/21. Okay. Initial reaction 5/21. Okay. Okay, let's discuss. We have only 5 more minutes for class. I want to do at least a few more questions. Okay, at least 2 doctors. So let's make 2 columns, doctors and dentists, T I said, right? So you can technically, if you want to select 5, it can be 0, 5, 1, 4. Of course, this is not possible because we only have a total of 4 dentists. So we can straight away rule out this. So it can be 2-3 combination, or 3-2 combination, or 4-1 combination, or 5-0 combination. These are the possibilities. In fact, for this one is what we answered. The earlier question was 1/42. A team of 5 doctors, the probability was 1/42. Right. Now, what is he asking in the second part? At least 2 doctors, which means he's asking the collective probability of all of these 4. Okay. Now, there are 2 ways, the long way and the short way. Long way would be, okay. So what is, in fact, what is the probability of selecting 2 doctors and 3 dentists? Will be 6 choose 2 times 4 choose 3 upon the denominator will be same for everything, 10 choose 5. What is the probability for this one? 6 choose 3 times 4 choose 2 upon the same denominator, 10 choose 5. Likewise on this one, right? You have to do all of this. And then this last one also was also exactly that 1/42. How did we arrive at the 1/42? Just to remind again, it was 6 choose 5 times 4 choose 0 upon 10 choose 5. So similarly, this quantity I'm not writing. So you have to add all of these numbers, right? Which is a bit of pain. Instead, the short method would be, it's in our favor that 0, 5 is not even possible. So which means this is the only other possibility, right? Let's say I find this probability is X. So my answer is just 1 minus X. This collection will have to add up to 1 minus X. The collection I'm looking at is just 1 minus X, because the first one is not possible. This is not X1. This is not possible. Not possible. Right? And this is easy to find. How much is it? 6 choose 1 times 4 choose 4 upon 10 choose 5. Right? So 1 doctor, 4 dentists, and of the total probability, right? So 6 choose 1 is 6, as we know. 4 choose 4 is also easy, 1, right? Because I have to select 4 dentists out of 4 dentists. There's only one way. I have to select all of them upon the denominator, which I recall was 6 into 6 into 7 when we did the simplification, which is what the 252 was, right? We can do it again, right? So 10, the denominator is 10 into 9 into 8 into 7 into 6 upon 5 factorial, which is 120. So ek bar kar lete fir ek bar. So this is 12 cancels off with, this is 6. So 6 into 6 into 7, I'll be lazy, I won't multiply it. So that the answer in this case, coincidentally, is 1/42 as well. So which, I mean, not coincidentally, this also works out to 1/42, right? So this is 1/42. The last one was also 1/42. Yeah, and that was coincidental in a way, because 6 choose. So this last one was 6 choose 5 times 4 choose 0. Now for this one, I'm doing 6 choose 1 times 4 choose 4. 6 choose 1 was same as 6 choose 5. 4 choose 4 was same as 4 choose 0. Therefore, the expected answer was same for 1/4, the 1/4 case as the 5/0 case. Okay, anyway, that was just a small observation. Bottom line, the case that we did not want, namely 1 doctor and 4 dentists, is 1/42. Therefore, the answer that we are seeking, which is the collection 1 minus X, will be the rest, which is 41/42. Does it make sense, guys? Yeah. And Ananya, just intuitively itself, your answer was wrong, right? At least 2 doctors, right? It should be a very high chance, given there are 6 doctors and 4 dentists, right? Even if it had been at least 2 dentists, it'll be slightly higher than, this is approximately 1/4, right? Very likely you will have at least 2 of each, but more so in favor of doctors, right? Given there are 6 doctors. So intuitively, the answer 5/21 does not be. So the reason I'm saying all of this intuitive is, let's say you're the last 15 seconds. You have to guess. And let's say there are 5 choices in AMC, A, B, C, D, E. There's negative marking, mind you. Okay, we'll come to all that a little later. But let's say you obviously are able to eliminate some answers like this. And it's only between B and E, you're not sure. Then it's worth taking a guess. So to take that intelligent guess, you should be able to eliminate very obvious wrong answers, right? Which is why I keep harping on intuition. Okay, does it make sense, guys? This approach, everyone. Kunsh, you're okay? You're still awake? Okay, that's good.
Yes, sir.
Shivank, I don't even know if you're awake because you're in dark. All okay, Shivank?
Yeah, so
Okay, Sharma, how is it so far? Okay, cool. We're just about reaching end of class. I'm just wondering, maybe I'll just do one more question, right? And then we'll stop. Okay. Permutation, combination, probability is all mostly like just plain logic. You don't need too much math, right? I mean, there is math, but you can do it with just plain logic itself. Okay, 4 different numbers are selected. Determine, and the x is the second largest. What is the probability that x is 2? Okay, maybe maybe we can do x is 7. Let's ignore the 2 and 9. It will be very similar. Let's do the 7. Can we do B part? Anyone has an answer for the B part? Whoever has done it so far. Shivank, did you do the homework, by the way? Did you have time to do it? I know you were a little sick in between.
so can you repeat?
Did you do this homework?
Yeah,
was
so
assigned.
I was able to do.
Okay, do you have an answer?
But there were many sums that I actually wasn't able to get.
There were 15 questions and this is around halfway through.
Yeah, I know.
Because-
So I didn't get this one.
Okay, yes,
Yeah.
go ahead,
I
Avinash.
did part A and I got 0 in that. So would that make sense? Just
Okay, let's see. Well, yeah, so you are picking 4 numbers, A, B, C, and D. And you want the probability that X, which is the second large, in fact, we'll call this X. A, B, X, and D. X is the second largest, right? So you want this to be 2, right? Which means you need 2 numbers below this, right? That's not possible because there's only
Oh,
one
so it
number
is
below
zero.
this. So it
Okay.
is 0. Probability of getting 2 is indeed 0. Probability of getting 7, let's do the same thing. So I'll replace X with 7 now, right? So which means we'll need one number at D, which is from 8, 9, and 10. From the set 8, 9, and 10, I'll have to select 1, which is 3, choose 1, which is 3 ways. And from the set 1, 2, 3, 4, 5, 6, I'll have to select 2 numbers for my A and B. So that's possible in 6 choose 2 ways. So in other words, the probability is, if I'm asked to select randomly 4 numbers, the denominator would be 10 choose 4, of which the favorable cases are I'm selecting 2 numbers from 1 to 6 and I'm selecting 7. There's only one way I can select 7, that's 1. Or if I want to write it, is 1 choose 1. Of the 1 7, I'll have to pick 1 7. That's 1 choose 1, which is obviously 1. Right? And of 8, 9, and 10, I'll have to pick 1, which obviously is 3. But using this notation, it's 3 choose 1. And that's it. Rest is very simple, right? You just have to figure it out, right? So 6 choose 2 would be, 6 choose 2 is how much? 6 into 5 by 2 into 1, which is 15. Okay, 1 choose 1 is just 1. As we said, 3 choose 1 is 3. So its numerator is 15 into 1 into 3. And the denominator is 10 choose 4. How much is that? 10, 9, 8, 7 upon 4 factorial, which is 24. 24, right? So 24 cancels with this to give 3. So it's 10 into 3 into 7 in the denominator. So I can cancel off some stuff. So it's 3 here, it's 2 here. So it's 3 over 14. Does it make sense, guys? Numerical simplification, all that is fine. Anyone can do it. Of course, that's important too. But logically, do you understand, all of you? Ananya, the 2 Ananyas, all of you, okay? Avinash, Kunal, Kunsh, Johan. Okay, all right, sounds good. Let's stop here for today. And then please finish the rest of this homework. I'll be assigning one more homework and I'll try to go easy. I understand there's some exams going on in school and all that. But definitely finish the rest of the questions, or in fact, the whole sheet if you have not attempted it at all. Now that you know, so redo the questions that we discussed if you have not done it at all. And then, yeah, we'll meet next Sunday. Okay, chalo, bye. I'll send the recording as usual.
Bye.
Bye.
Thank you.